Stop crying over yesterday and start smiling for future. So students, I welcome you all to this amazing platform of PW English. My dear students, today we are going to start with our chapter, that is classification of elements and periodic properties. And till now students, we have covered the very basic thing, that is what is modern periodic table, what are the tricks to remember the elements. Yes. Now in this particular session today, that means lecture number 4, what are we going to do in our batch? Ma'am, today we are going to cover the most important topic of ours, that is going to be atomic radius. Now students, let me tell you, till now the topics that we have done in lecture number 1st, 2nd and 3rd, they were the basic, okay. That means you have to learn the elements as per the periods, as per the groups, okay. Then only these periodic properties, the variation and periodic properties will be helpful for you and you will be able to learn it out if you have already studied the session, lecture 1st, 2nd and 3rd. If till now you have not learned the elements, you have not learned the periodic table, yes, you may feel some of the problem in understanding the concept, but if I'll, explain and write it over here that yes, see, this is the period that you have to learn, this is the period you have to do. So by writing again and again, by understanding the concepts, it will be more clear to you. So, if you have not seen the previous session, first of all, go and see the previous session, learn the tricks to remember the elements in the periodic table. Just see it once, okay? I'm not saying repeat it twice or thrice, just see it once and then start with this session. You will automatically get that, yes, how we have to, summarize and revise it. Now coming to my topic, as you all know, this is our Nexus batch and here I'm going to start with your which session today, ma'am? Today we are going to start with lecture number 4th. So now what are we going to cover in this particular lecture? The very first thing that I was discussing now only was about the periodic properties, right? So periodic properties, mainly we are going to cover atomic radii, ionization energy, okay, then electron gain enthalpy, electron affinity, electronegativity. These all are periodic properties that we are going to study, students, okay, one by one. So today in this particular session, lecture number 4th, we are going to do your atomic radii and its types. But before understanding atomic radii, you should also know about the term, what is effective nuclear charge. Yes, and at last I'm going to explain to you the variation along the period and the group where you require the tricks to remember the periodic table elements. Okay, there you are going to write, for example, I will ask you, students, write down the group number 13 elements, write down the group number 16 elements, write down the period number 2 elements. So for that you should revise and learn the periodic table elements. So that will be required over here in the 4th segment of ours. Yes everyone. Now starting with the very first topic of ours, what are we going to do? Meet your friends, students. Yes, both of them are always ready to welcome you in our class. So now what are they asking? Let us see. Basically over here she is asking you, hello my shimmering stars, have you revised the previous session? If not, go and revise it. Yeah, and he is saying basically, hi friends, get ready for which topic today? For atomic radii today. Yes. Okay, let us start with the very first segment. As I've already told you that students, we are going to proceed with periodic properties. Though in the previous session, I've already made you understand about the term periodicity. What is periodicity, students? I don't know whether you remember or not, but let me give you a quick review over here. What is periodicity? What is periodicity? Periodicity is basically the repetition of properties, or I would say the physical and the chemical properties that you are going to see are going to repeat after a particular interval. Let us consider in a group, okay? In a group, if I'm talking about the elements, they have the same periodicity. That means they have physical and chemical properties that are similar to each other. That is what I'm saying is referred to as your what? The term periodicity. Okay, the periodic properties. So as I've already told you, that which periodic properties we are going to cover, which periodic properties we are going to do. The very first is going to be atomic radii. The second one is ionization energy. The third one is electron gain enthalpy or electron affinity. And the fourth one that we are going to do is electronegativity. Okay, let us start with the very first segment, that is atomic radii. Before this, let us understand about what is effective nuclear charge. See, if I'll talk about the very basic definition of atomic radii, consider this is my nucleus, okay? This is my first shell, consider this is my second shell, and this is my third shell. We are considering an element which has basically 3 periods in it, that means 3 shells in it. And this is the outermost electron that is present in this third shell over here. So what is atomic radii basically? Atomic radii is the distance of the nucleus at the outermost shell. If outermost shell electron, so distance between the outermost shell electron and the nucleus is referred to your as atomic radii. So what is atomic radii first of all, students? What is atomic radii or atomic radius? I would say it is the distance. It is the distance between nucleus and outermost shell electron. So this is what is atomic radii. Yeah. Now what happened basically? The very first term which I am making you understand over here is effective nuclear charge. What do you refer to as effective nuclear charge? Let us understand them. Now what happens is basically, see, if I am saying that basically there is 3 shells over here, that means first shell, second shell is completely filled. That's why electron now is entering into third shell. That we always remember, the very first shell holds how many electrons? 2 electrons. Second shell will hold how many electrons? 8 electrons. Yeah, I guess this is clear to you all. So if it is first shell, it contains 2 electrons. If it is second shell, it contains 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8. And third shell basically contains 1 electron, right? The outermost shell contains 1 electron. So what is happening over here? See. Now, I said you what is atomic radii? The distance between the center and the nuclear and the outermost shell electron is what is atomic radii. What is effective nuclear charge? The charge exhibited by nucleus on the outermost electron. Now, what is the charge exhibited by the nucleus on the outermost electron referred to as? See, for example, let me tell you. If I am a positively charged species, I will be attracting a negatively charged species. If I am a negatively charged species, I will be attracting a positive one. Why? Because unlike charges, that means opposite charges attract each other. Like charges will repel each other. Positive will repel each other. Negative will repel each other. So what is happening over here? This positive is basically attracting this electron because electron is a negatively charged species. So it is attracting it towards it, right, students? That means there is an attractive force between them. So the force exhibited by nucleus on the outermost shell electron is effective nuclear charge. What is nuclear charge? Nuclear charge is the charge exhibited by nucleus on outermost valence shell electron. This is what is a nuclear charge. Let us understand this one by one. What is written over here? So effective nuclear charge in a polyelectronic ion, right, where there are many electrons in atom, between the outermost valence electrons and the nucleus of an atom, there exists a number of shells containing electrons. All of them contains electrons. Let me tell you one thing. Sorry, I didn't told you about it. I told you nuclear charge. The term effective nuclear charge is almost the same, but there is a very slight difference between nuclear charge and effective nuclear charge. Though I was again and again saying effective nuclear charge, that is nuclear charge. Charge exhibited by nucleus on the electrons. What is effective nuclear charge, students? It is kind of a same thing, but you have to understand that effective nuclear charge is basically Z effective. Effective nuclear charge basically is Z effective, which is equivalent to what? Now, this is equivalent to Z minus sigma. Now, what is this sigma? This sigma is shielding effect or screening effect. Let us understand this key concept that I have explained you over here. Let us understand this key concept which I have written over here. See, in a polyelectronic atom, between the outermost shell valence electrons and the nucleus of an atom, there exist a number of shells which contain electrons, which I have represented with the pink color over here. Due to the presence of these inner electrons, the valence electrons are unable to experience the attractive pull. See, this white color which I have represented is basically the force of attraction which the electrons experience because nucleus is attracting it. Nucleus basically is applying force of attraction, attracting that electron. And now see, if something is attracted something, so it will come closer. No, if I am pulling some force on the outermost shell electron, I am telling that electron to come towards me. So basically what is happening, this nucleus is exhibiting some kind of force on this electron so that this electron can come inside. But see here what happens now. These electrons, as you can clearly see, the electrons over here, the pink color electrons over here, now they are negatively charged species. They are negatively charged species. And what is happening? Nucleus is bringing the yellow electron towards it. But these pink electrons, though they are negative and also the electron which is coming inside is negative, they both will experience what? They both will experience a repulsion. They won't let the outermost shell electron to come inside towards the nucleus. They are sitting at a position, they are pulling some force. Okay, what is happening? Nucleus is pulling some force. So outermost shell electrons, what they do? They make a shield over the nucleus so that the outermost shell electron cannot come inside the nucleus. Repeating again, see, if I am a nucleus is exhibiting some force on the outermost shell electrons and I am pulling it towards me. Now, the inner electrons which are creating a shield over here in front of me, they will, do the repulsion. They won't allow it to come, close me. So, they will do repulsion, electron repulsion. So, the charge at that spot of time, which our electron is having at that spot of time, the charge from the nucleus, is your effective nuclear charge. Nuclear charge is again yet the charge on that, but effective nuclear charge is that charge which is being created when there is a shield being exhibited by the inner electrons in order to prevent the outermost shell electron to come inside. I guess this is quite clear. See now. Due to the presence of these inner electrons, the valence electrons are unable to experience the attractive pull of the actual number of protons in the nucleus. See, nuclear charge is exhibited by nucleus, and nucleus has which kind of charge? Positive. Why positive? Because you very well know, ma'am, that nucleus is made up of neutrons plus protons, no? Neutrons is neutral in nature, but protons is positive in nature. Due to this, nucleus has a positive charge, no? Due to this only nucleus has a positive charge. So that is what it is saying. These inner electrons act as a shield between the valence electrons and the protons in the nucleus. So they are creating a shield so that it cannot come inside. Got my point? Now you know what is effective nuclear charge. This Z is atomic number. This sigma basically is the value of the shielding effect or the shielding power that we are seeing over here. Yes, students, now see. Thus, the presence of the intervening, that means shielding electron, reduces the electrostatic attraction. This is what I am saying. If there was no such electron present inside, then electron can easily come inside. But yes, if there are some shells which contain some electrons, those shells will contain electron, then only, you are creating more and more shells, yeah? First shell is being filled, then second, then third, and so on, right? So basically what happens is, if they are shielding that, so the electrostatic force of attraction which was basically being exhibited at that spot of time when there was no such electron inside, and at that spot of time there is as much electrons, that basically will now decrease. That strong electrostatic force of attraction will decrease because electron-electron repulsion will start. So this is what I am saying is, the presence of intervening electrons reduces the electrostatic attraction between the protons and in the nucleus. The valence electron, because intervening electrons repel the valence electrons, yeah, because it was attracting, it would not be as strong because now electronic repulsion is taking place. So, the effective nuclear charge, that is Z effective, is the charge which is actually felt by the valence electron from the nucleus. Yeah. So, this is given by this formula which I have already told you. Z effective is Z minus sigma, where Z is actual nuclear charge or the atomic number you can say, and sigma is basically the shielding power or the screening constant. Clear everyone? Yes. Okay. So, if I ask you, then let us consider that basically nuclear charge is increasing. Okay, if I am saying students, nuclear charge, let us consider it is increasing, or if I am saying Z effective is increasing, so what will happen? Electron will come inside now. the charge from the nucleus on the outermost is increasing, so it will come inside. That means what happened to the size? Size will decrease, no? Because outermost electron is moving inside, is coming closer. So the size is being decreased of the nucleus to the outermost shell electron. It is being decreasing. That means size reduces. So we get to a conclusion that nuclear charge is inversely proportional to size, everybody. It is inversely proportional to size. Clear, students? Clear? Shall I move on to the next one if it is done? So this was an introduction to effective nuclear charge, because this is a factor which basically is going to affect the atomic radii, which you are saying. Nuclear charge increases, atomic radius decreases because it comes more closer. The outermost shell electron comes so closer. That's why it happens. Now students, let us start in brief about atomic radii. What are the types of atomic radii and what are the trends, right? So atomic radii definition, I've already told you. The distance of the distance from the nucleus to the outermost shell valence electron is referred to as your atomic radii. So atomic radii is taken as effective size, okay, that is the distance of the closest approach of the atom to another atom in a given bonding state. Now these are explaining you the definition with regard to the types, okay. Atomic radii is quite simple, the distance from the center to the outermost shell electron. Now there are four kinds of atomic radii, one is missing, I'll mention it over here. The very first one is covalent radii, the second one is van der Waals radii, third one is metallic radii, and there is also one more, that is your Ionic radii. So these are the four types of radii that you have to study, which we are going to study one by one. Okay, let us start with them. The very first comes over here is covalent radius. The very first type comes over here is covalent radius. Anybody, do you know what is a covalent radius? See, covalent radius, the word itself says that there is a covalent bonding in them. That means in covalent radius, we shall be observing which kind of bonding? Covalent bonding. Now, do you have any idea what is a covalent bonding? What do you refer to as a covalent bonding? Covalent bonding in other terms is referred to as sharing of electrons. What is, ma'am, covalent bonding? In other terms, students, it is basically sharing of electrons. Now, how it is going to take place? Let us take an example. For example, students, if we have, AA compound over here, okay, A molecule over here, that means A and A, right? There are two similar atoms in this particular molecule, A and A. That means they have same electronegativity. Now, what is electronegativity? Electronegativity basically is tendency to attract shared pair of electron towards itself. Writing it again because you are new to this term. Electronegativity is represented as En. Electronegativity, what it is exactly? It is, tendency to attract shared pair of electron towards itself. What is electronegativity? Tendency to attract shared pair of electron towards itself. Let us consider, see, if they have AA, that means they have same electronegativity. That means they are sharing, if they are having any single bond, that means they are sharing equal part of that single bond, equal percentage of the electrons in the single bond. But if I'll talk, let us take in case where I have A and B. Let us consider A and B are making a bond, right? Now, you very well know that there are two electrons on a single bond, yeah? In actual, it does not look like this. A and B, that means different molecules, that means they will have different electronegativity. That means they'll have different electronegativity. So if they have different electronegativity, what we will observe that if it is A, if it is B, and I am saying that B is more electronegative, that means electrons are still present on the single bond, but it will be quite shifted towards B. Electrons are still being shared by both of the atoms, but they are quite shifted towards B. Why? Because I am here saying that B is more electronegative. I am taking an example, more electronegative than A. So that means C, tendency to attract shared pair of electron towards itself. So it is attracting pair of electron towards itself. So this is what is electronegativity, right? So basically what is covalent radius? It is covalent bonding. What is covalent bonding? It is sharing of electrons. How do we share electrons? How the electronegativity concept came over here? This I have explained you, though we are going to understand electronegativity in depth also. Let us see if it is your A molecule. Let us consider, this is your same molecule. Let us consider AA case. If AA are sharing electrons with each other, so this is going to be the structure. If they are sharing electrons with each other, so this is going to be the structure. Yeah, they are sharing their part. They are sharing the bond, right? So this is what is, this is sharing of electrons. This is sharing of electrons. So what is going to be the covalent radii? See, for example, this is your atom A. Let us consider this is your atom A. This is another atom A. Both of them are sharing this region. So this is the sharing region of their electrons. Now what is covalent radii? The covalent radius, you have to take the distance from its radius to the distance from its radius. Join them. This is basically D. When you are going to do the half of that D, the half of that distance, you will obtain what? You will obtain the radius R. This radius is basically the covalent radii, which comes out to be what? Which comes out to be distance between A and A radius by 2. Okay. Now this is for same atoms. This is for similar atoms. This is for similar atoms. If you have a different atoms, how you are going to calculate covalent radii? Let us consider we have radius A and we have to calculate radius, covalent radius for A and B. So it is going to be the radius of A plus radius of B minus 0.09 and delta X. I am writing, sorry. Radius of A plus radius of B minus 0.09 delta X. Now this delta X basically, it's not X basically, though I'm telling you in detail, you will get to in electronegativity. So this is change in electronegativity. What it is? Change in electronegativity. That means electronegativity of A minus electronegativity of B. The higher electronegativity minus the lower electronegativity value, you will keep it over here. And here you will keep the radius of first and radius of second. So you will obtain the radius for different species by the help of this formula. And for similar atoms, the radius is quite simple. The distance of A and A divided by 2 comes out to be for similar atoms. For dissimilar atoms, you are going to use this formula. Yeah. So let us read it. It is 1/2 of the distance between the centers of two nuclei. It is 1/2 of the distance between the centers of the two nuclei bonded by, bonded by an angle covalent bond as shown in the figure. Clear, students? I guess now covalent radius is quite clear to you. Covalent in other terms again referred to as your what, ma'am? Sharing of electrons. Very simple. So whenever I am saying covalent, you have to draw the structure like this. Yeah. So its radius is quite simple. The distance from here to here, you have to do its half. This is going to be the radius, the actual radius of the covalent radii. Yeah. The distance between both of them divided by 2. Clear, students? Shall I move on to the next one? This was about covalent radii. Now let us understand about van der Waals radii. See, in the case of van der Waals radii, let me tell you first of all, van der Waals radii will occur between the molecules. It is valid for inert gases. Used for which kind of gases, ma'am? Inert gases. See, van der Waals radii, let us consider this is your one molecule, this is another molecule, so distance between both of them. So this is the distance d between both of their radius, you have to divide it by 2, you will get the van der Waals radii. You will get the what? Van der Waals radii. So that you can clearly see that there is no sharing of electrons. These occur in the case of inert gases, these occur in the case of molecules. So they basically are distance from first atom to the second atom divided by 2 is van der Waals radii. So it is 1/2 of the internuclear distance between two adjacent atoms in the nearest neighboring molecule of the substance in solid state as is shown in your figure. This is van der Waals radii. If I'll compare van der Waals radii and covalent radii, which is more in size, you can clearly see the distance in van der Waals is more, but in covalent it is sharing, so the distance is quite less in comparison to this one. So I can say that radius of van der Waals till now we have seen van der Waals radii is more than the radius of covalent one. Yeah. This is the first conclusion that we can draw from the given things that we have studied till now. Let us move on to the next one. Now, comparison of covalent radius and van der Waals, which I have already told you, but yes, let us read it. The van der Waals force of attractions are weak. in van der Waals radius, there is van der Waals force of attraction. In covalent radius, there is covalent bonding. Yeah. So van der Waals force of attraction, basically students are weak, so that the internuclear distance in case of atoms are held by van der Waals force of attraction, which are much larger than those of the covalently bonded atoms. Okay, now the van der Waals forces of attraction are weak, but what are they saying is the distance between them becomes larger than the covalent bonded radii. Yeah. Therefore, van der Waals radii are always larger than the covalent radii. Covalent radii is smaller because there is sharing. So, they come closer to each other and then they indulge in each other. But yes, the van der Waals radii are present at a far distance from each other. That's why it is larger in size. Then comes your metallic radii. Let me tell you about metallic radii. In metallic radii, we see in the case of solids, and here exists metallic bonding. Here exists what, ma'am? Metallic bonding takes place over here. Yeah, it is also referred to as crystal radius. Why? Because it is seen in the case of solids. Yeah, in solid state chapter also you will be understanding about metallic bonding. So always remember, metallic bonding occurs between kernels. It occurs between kernels and free electrons. It occurs between kernels and free electrons. Though in detail this you will study in your class 12th, but yes, you should know that metallic bonding occurs between kernels and free electrons. So it is 1/2 of the distance between the nuclei. Now in metallic bonding they will touch each other. Why? Because it occurs in the which state? In solid state. It is seen in which? Solid state. So in solid you should know that particles are tightly attached to each other. In solid state, particles are tightly attached to each other. So here you will be seeing that first atom is sitting quite close to the another one. So what will be the radii? You will do the distance from their radius divided by 2. So this comes out to be the metallic radii. Quite easy. Metallic radii of an element is always larger than its covalent radius. Why? Covalent basically gets into each other because they are sharing electron. This is metallic and this is van der Waals. So basically if I write the trend, always remember that van der Waals radii is larger, then comes your metallic one, and at last comes your covalent one. Yes, so do remember this as well, students. Everybody please write it down. Now see, metallic radii of an element is always larger than its covalent radius. It is due to the fact that metallic bond, that means electrical attraction between the positive charge. Positive charge over here is the kernels of an atom, and the mobile electrons, that means free electrons, is weaker than the covalent one, and thus the internuclear distance between both of them is longer than the internuclear distance in covalent one. So thus the covalent, van der Waals and metallic radii are in this magnitude wise. This is the answer which I have already written over here. Van der Waals will be highest, then the crystal one, that means metallic one, and then the covalent one. Clear everyone? I am getting a side, everybody please write it down. Moving on to the last type of the radii, that is ionic radii. Everybody write it down once. Clear? Let's now understand about ionic radii in detail. What is ionic radii? First of all, let us understand about ionic bond. See students, ionic bond exists between two kinds of ions. That one is cation and another one is anion. Now, what is cation and what is anion, students? Cation is something which carries a positive charge. Anion is something which carries a negative charge. So, when there is an electrostatic force of attraction, what occurs over here? Electrostatic force of attraction. When there exists an electrostatic force of attraction between cations and anions, they form ionic bond, right? So again, ionic bond will be distance between the cation and anions, right? So basically, it is effective distance from the center of the nucleus of the ion, that is cation and anion, up to which it has an influence in the ionic bond, is referred to as your ionic radii. Always remember, okay, more the negative charge, more is the size. More the positive charge, lesser is the size. Remember, cations are smaller in size and anions are larger in size. Clear everyone? More the negative charge, more is the size. More the positive charge, lesser is the size. Yes? Now students, let us understand this also as well about ionic radii. See, Pauling's empirical formula for ionic radii is that ionic radii is inversely proportional to nuclear charge. What is nuclear charge? Which depends upon the protons, right? Or the charge exhibited by nucleus on the outermost shell electrons. So if nuclear charge is increasing, ionic radii will decrease. Now this is only for isoelectronic species. What is isoelectronic species? Iso referred to as same, electronic refers to as when there are same electrons. Yeah, a cation is smaller than its parent atom, while anion is bigger than its parent atom, already told in the previous slide. Next, among isoelectronic species, the cation with the greater positive charge will have a smaller radii, and anion with a greater negative charge will have a larger radii. This also I have told you in the previous slide, that if there is more negative charge, that means the radius is larger. If there is more positive charge, that means radius is smaller. Clear everyone? So they will ask you in question paper regarding the trends about, they will give you positive and the negatively charged species. They will ask you which has larger radii or the less radii. Yeah. Now students, come the next portion, that is variation along a period and a group. But before that, let us discuss about the factors affecting it. The very first factor that affects the atomic radii is effective nuclear charge. Now see, it's very simple. If you are increasing the nuclear charge, what will happen? Now only we have started. If you are increasing the nuclear charge, the size will decrease. What is size? Size is atomic radii. Yeah. So what I can say is nuclear charge is inversely proportional to atomic radii. Or in bracket, you can even write size. The very first factor that affects basically is going to be this one only. Everybody write it down so that I can move on to the next part as well. Everybody write it down so that I can move on to the next part as well. Now see students, second factor is shielding power. I want to tell you about shielding power. See students, S orbital has more shielding power than P, then D and then F. This is also going to help you in the upcoming variation portion. What is shielding power? The inner electrons, they are creating a shield so that the outermost cannot come inside. That is what is the shielding power, no? So S orbitals have higher shielding than P, then D, then F. So that means F has poor shielding, right? If it is poor shielding, if it is poor shielding, students, that means inner electrons cannot protect the outermost electron to come inside. So what will happen? Outer will come inside, that means size will decrease. So if it is poor shielding, size will decrease. And if it is good shielding, students, that means they are protecting very well. So what will happen? If they are protecting very well, they won't allow it to come. They will put some repulsion, because electron repulsion will occur. That means size will increase. That means size is going to be increased. Clear everyone? Everybody write the second factor. Now we will be moving on to the variation segment. This is also again very important part which I have told you over here. Shall I move on to the variation part now? So here comes variation. So let us talk about the variations along a period first of all. See, along a period, if I am talking about, let us talk about the second period, okay? This is your second period elements. Now see students, when you are moving from left to right, always when I will be discussing about the trends in a period, I will be moving from left direction towards right direction. So when I'm moving from left direction towards right direction, what you are observing, that in the case of lithium, let us consider in the case of lithium, what are you observing? Lithium, hydrogen, helium, lithium. That means what? Third, it has atomic number 3, it has 4, it has 5, 6, 7, 8, 9 and 10. Yes. So if I'm talking about this lithium which has 3 as an atomic number, that means if I'm going to write the configuration, it is going to be what? sorry, not configuration, let us say that if it is atomic number 3, that means how many protons are there over here? It is neutral species, so protons are also 3. That means here it is 3 protons, ma'am, at the center, right? And it is second period, so if it is your first shell, this is your second shell. Let us talk about beryllium. It has 4 protons, then it is first shell, again second shell. All are in the same period, so shells are same. They have 5 protons, second shell. In this also 6 protons at the center, so this is, let us consider this as your nucleus, okay? So I am creating 2 shells. This is your nucleus. This is your nucleus, 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 second shell, and so on. So what do you observe when you are moving from left to right? Number of protons increases. Only protons are increasing. Number of protons are increasing, not shell. Shell is same. They belong to the same period. So n value is same. N value is same for all of them. Shell value is same for all of them. Only protons are increasing. That means nuclear charge is increasing, because nuclear charge is what? The protons and the neutrons, and it is positively charged. It is the charge exhibited from the nucleus to the outermost shell electron. That means when we are moving from here to here, if protons are increasing, that means more charge will be applied on the electron. Protons basically are positive, so it will pull more electrons, right? That means when we are moving from left to right, what do we observe, ma'am? Nuclear charge increases. Yes, so now you very well know, only we have studied the the factors that affect basically. So if nuclear charge is increasing, what will be the effect on size? We very well know, ma'am, nuclear charge is inversely proportional to size. If nuclear charge increases, size basically is going to decrease. That means size basically decrease. That means this is going to be the trend. This should be trend, but no, this is not the correct one. It basically decreases. This is fine, but this is not the correct one. Neon students, neon over here students, neon over here will have, the highest size. Why it will have the highest size? Because neon basically is an inert gas, and inert gases, students, exhibit van der Waals radii. And they exhibit which kind of radii? Van der Waals radii on the van der Waals forces. If there is van der Waals forces, then that means it has a van der Waals radii, which is the highest one. So what according to them will be the trend of ours? Now according to them, the trend will be neon will have the highest radii because it is van der Waals. Then the trend will be nuclear charge increases and the size decreases. So it will be lithium, then it will be beryllium, then it will be boron, then carbon, then nitrogen, then oxygen, and then fluorine. That means fluorine have least radii, the smallest radii among the period number second. Clear everyone? Everybody write it down. Very, very, very important. This is along the period number 2. Here you can even mention this is about period number 2. Clear everyone? Clear everyone? Period number 3, students, and the next period where lengthener contraction will be there. We will do that in the next lecture. I don't want this lecture to be a hectic one. Step by step, we will proceed. Now I will show you the trend along the group. I guess along a period everybody has written. Everybody has written along a period. I will explain this again and then I will move on to along a group. First of all, write it down. See, we have seen that there are factors just as nuclear charge. Nuclear charge is something which nucleus exhibits on the outermost shell electron. If nuclear charge increases, outermost shell electron, it will pull it more, it will come closer, so the size will decrease. This we will know, right? So when we are going to write it, we see that they have the same number of period. That means they have the same number of shell. That means second shell, 2 shells over there, right? Now, everything will depend upon what the nuclear charge, the number of protons. More the protons, more will be the attraction because more people will attract it, right? Here only 3 people are attracting, 4 are attracting, 5 are attracting, 6 more are attracting. I'm saying people over here just to understand so that you can correlate it properly. There are more, protons to attract it to the electron, right? Positive and negative attract each other. So that means nuclear charge increases, right? So size will decrease because they're inversely proportional. But there is an exception that neon basically is an inert gas and it exhibits which kind of radius? Neon basically will exhibit your van der Waals radii, and so it will have the highest value. So first it will be neon, then lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine. Coming to the next part, this was variation along a period. Let us read it from NCERT as well over here. The NCERT highlight says that atomic size generally decreases across a period. We have seen decreases, yeah. For the elements of second period, it becomes within the period, the outer electrons are in the same valence shell and the effective nuclear charge increases. They are saying shell is same, but what increases? Effective nuclear charge increases. As the atomic number increases referred to as protons are increasing, right? Resulting in increased attraction of electrons to the nucleus, due to which attraction increases. This is the reason which I have written in the NCERT. You can even see the trend over here. You can even see the trend over here. Even see the trend. They have not mentioned neon over here because it was inert gas. It will have the highest one. It is a van der Waals radii. They have shown you the other values. See, lithium has the highest, then beryllium, boron, carbon, nitrogen, oxygen, fluorine. Fluorine has the least value. Similarly, they have given you for the period number next one, right? But I have only shown you till now period number second. Third, fourth and fifth we will be doing in the next lecture. Yeah. Let us now discuss variation along a group. Yeah. Along a group. Now students, when I am saying variation along group, that means I am talking about what? From top to bottom. We have studied elements from top to bottom. Let us consider your group number first. What were your elements in group number first? These are your elements in group number first: hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Yes, everyone. So see what happens over here. When you are moving from top to bottom now, yeah, what happens? Now see, hydrogen basically lies in first period, N here is 1. Lithium lies in second period, N here is 2. This lies in third period, N is 4. This lies in fourth period, N is 4. This lies in fifth, this lies in sixth and this lies in seventh. Right? They all have one electron in the outermost shell. So let us consider, if I have to draw the structure of hydrogen, this is the first shell of hydrogen containing one electron. Lithium, this is nucleus, this is first shell, this is second shell containing one electron in the outermost shell. That's why they are in group number 1, because they contain one electron in the outermost shell. Let us draw about sodium. This is your nucleus, first shell, second shell, third shell, and it contains one electron. Let us consider of potassium. So in the case of in the case of potassium, it is nucleus, it is first shell, second shell, third shell, fourth shell, it contains one electron. Let us consider the case of rubidium. It is nucleus, first shell, second shell, third shell, fourth shell and fifth shell, and so on, students. Similarly, you can draw for the case of cesium. Nucleus, first shell, second shell, third shell, fourth shell, fifth shell and sixth shell, and last for francium it will be 7 shells. So what are you observing? What is atomic radii? Atomic radii is the distance from the nucleus to the outermost shell electron. So distance over here in the very first case is this much, over here 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 is this much, and over here is this much. So what are you observing? When are you moving from top to bottom? Basically, ma'am, number of shells increases. What happens when you move from top to bottom? Number of shells increases. If number of shells are increasing, that means distance between the atomic radii and the outermost valence shell also increases. So distance increases, that means size increases. So top to bottom, number of shell increases and then size increases. So this is going to be the order of the atomic radii when you move from top to bottom. Clear, everyone? Kindly draw this so that we can start reading with the NCERT highlight of this also. This is about group number 1 and 2. The trend will remain same. Let us move on and read the NCERT highlight for this as well. NCERT highlight is within a family or vertical column, that means I am talking about a group, of the periodic table, the atomic radius increases regularly with atomic number for alkali metals and halogens. Okay, only we are discussing about them because there are some exceptions in other cases also. So I am telling about group number first and group number second, and alkali metals basically group number first, and halogens are basically group number 17, right? So basically in that case, what happened? The principal quantum number n, that means the shell value increases, right? And the valence electrons are farther away from the nucleus because shell increases. This happens because the inner energy levels are filled with electrons, right, which serve to be shield the outer electrons from the pull of nucleus. Consequently, the size of atom increases as reflected in the atomic radii, because shells increases, so distance increases, hence size increases. These are the values that they have given you NCERT. You can clearly see that size basically is increasing. Clear, everyone? Now there is also NCERT highlight for Ionic radii. For ionic radii also there is an NCERT highlight. The removal of an electron from the atom results in the formation of cation. How cation is formed? When you are removing electrons, you understand. For example, if I am a neutral species, that means equal positive and equal negative. If you are taking negative charge, if you are removing negative charge, I will be left with positive, that means I am a cation. If I am a neutral species, I have equal and positive and negative. If you are taking a negatively charged, I will be positive. If you are taking a positively charged, I will be negative. So this is how cation and anions are formed. If you are taking an electron, a negative one, you will be left with positive, you are a cation. Whereas gain of an electron, if you are accepting an electron, you will become what? You will become an anion. The ionic radii can be estimated by measuring the distance between cations and anions in ionic crystal. In general, ionic radii of elements exhibit the same trend as atomic radii. The trend is same. A cation, a cation is smaller than its parent atom because it has fewer electrons. I have told you that anion is larger in size, cation is smaller in size. So they are saying cation is smaller than the parent atom because it has fewer electrons, while its nuclear charge remains the same. The size of an ion will be larger than the parent because basically it is accepting one more electron, okay, which was result in increased repulsion. When there is more repulsion, the distance increases. That's why an ion is larger in size. Clear, everyone? Now, students, let's practice some questions. So basically, are you ready, shimmering stars? Now see, students, today each and every question over here will be as your homework. Why they will be as your homework? Because today's topic, I want first you should analyze by your own, then we will practice question. So that means in next class, when we are going to start, the questions that I have given you as a homework will be discussed first of this session. Not of all sessions, of all sessions, homework question will be discussed at the last session that I've already told you, at the last lecture of this chapter. We will discuss all homework questions, but for this atomic radii, I want first you should try. We have done only one period, one group, okay. The another one, see, S block 1 we have done, S block will remain same, the group 1 and group 2, the content will remain same. For period 2, I have already told you, right? For the next one, we will be discussing in the next lecture, but yes, I want you all to practice once. So first problem question that they have given you is NCERT in text question, that is your homework. You have to write the answer in the comment section. Also in the next class, first we will discussing these homework question, then we will end up with the trends of variations along a group and period which are left of atomic radii, and then we will start the next periodic property, that is ionization enthalpy. So first NCERT in text question, which is your homework, is let us consider this is the first homework question. So which of the following species will have the largest and the smallest size? Already told you, students, the one which has more negative charge will have the largest size, the one which has more positive charge will have the smallest size. Yeah, cation have smaller size, anion have larger size. So this is the first homework question. Now comes your second homework question for today's class. That is basically which of the following alkali metals has the smallest size? Now this you very well know. Now only we have done this. Now only we have done this. So which of the following has the smallest size? Cesium, rubidium, sodium, potassium. Yeah. Let us see the next question. You can pause the video and write the question for your own. Now comes your question number 3 as a homework. Let us read it. Which of the following ionic species has largest size? Repeating again, the trend is going to remain same as of atomic radii. Trend is same for them. Yeah, so you have to just see along the trend. Let us see the next fourth homework question over here. The fourth homework question is chloride ion and potassium ions are isoelectronic. Then first, A is their sizes are same. B is Cl negative ion is bigger than K positive ion. C is K positive ion is relatively larger. D, their sizes depend upon other cation and anion. Right? Moving on to the question number 5th as your homework. That is, which one of the following is correct? Increasing order of size. Increasing order of size. Clear? Clear, students? So yeah, let's give only 5 questions as a homework, not more than that. Other we will practice in the next class. So yes, students, now we shall end our today's class over here. I hope so today's session was clear to you, was an interesting session. Now we will be meeting in the next periodic property in the next lecture. So do solve the homework questions. We will be discussing all of them in the next session as well. So thank you so much, my dear students. Keep smiling, keep learning. Thank you so much and take care.